So this video will be integrating with basic integral forms, basic antiderivative forms. So you should have a list of those forms available so you can see where we're getting this information. And the first is going to be just our basic power rule. So that's the integral of x to the n power dx is going to be equal to x to the n plus 1 over n plus 1 plus our constant of integration plus c. If we have just a constant term, just a number, let's just say we want to integrate 2 dx. Well, we can think of this as 2x to the 0 power. You don't have to write it like that, but you can think of it that way. And then that's going to be 2x to the 0 plus 1 over 0 plus 1, or simply 2x plus c. That's for a constant. We can also integrate a sum or a difference by simply integrating or finding the antiderivative of each term separately. For example, the integral of x squared plus 3x plus 2 dx. We can integrate both terms separately, will be x to the 2 plus 1 over 2 plus 1 plus 3x to the 1 plus 1 over 1 plus 1 plus 2 times x plus c. And we want to simplify that, x cubed over 3 plus 3x squared over 2 plus 2x plus c. But we can also integrate a sum or a difference of transcendental terms. For example, the integral of e to the x plus sine x dx. Now we're going to integrate the basic form. The integral of e to the x dx is simply e to the x plus c. And the integral of sine x is equal to a negative cosine x plus c. And so we can just substitute that in here. The integral of e to the x is e to the x, plus the integral of sine x is negative cosine x. And then we only need 1 plus c, and that's it. So it's really important that you learn the basic forms so that you know how to treat each term that you're given. Sometimes you're going to want to rewrite terms before you integrate. So for example, let's say I have 1 over x cubed dx. I'm going to rewrite that as the integral of x to the negative 3 dx. And that will be equal to the x to the negative 3 plus 1 over negative 3 plus 1, which will be x to the negative 2 over negative 2, which we can simplify as 1 over, that's going to be a negative, 2x squared. If we have radicals of any sort, say square root of x dx, we want to write them with rational exponents. So that's going to be x to the 1/2 dx, and that gives me x to the 1/2 plus 1 over 1/2 plus 1, gives me x to the 3/2 divided by 3/2, and we can simplify that. Dividing by fractions is easy as pie. You flip the bottom and multiply. So that gives us 2/3 x to the 3/2 plus c.